Hello again. Let's continue with our Rust on ESP32. Last time we ended up being able to toggle the light on and off based on a web command. So that's calling a get command to the root of the embedded web server on the device, and yeah, that toggles it on or off. So what I wanted to do is to extend that today to have a bit of upgrade, so we can not only switch on and off, but we can choose the intensity as well as the color, because it's like a RGB LED. So but before we do that, there was a update. We had to do a bit of a workaround last time, as there was a bug in the ESP service crate that had that didn't compile against the IDF update, the IDF itself. So we had to do, there was a patch on master, so if we refer to the Git it worked, but if we used the released patch it didn't. But fortunately the bug was fixed and there was a new release. So that's nice. So we can just use that and no longer use the Git reference. So we can just remove the patch part and update this one to 46.1, and that should all work out now. Okay, so what we need to do. If we want to use RGB, we need to communicate that somehow. Now we just do an empty get to the root, which is not good enough. We need to somehow say what color we want the light to be. So there are many ways to transfer request data in a web API, of course. One would be to use a path. It's in this case a bit weird, but you could. That's actually quite difficult in this implementation. There is no where is it? There is no intelligent mapping. In some cases you could do something like point to a variable here or something like that. We can't do that. We could also add it as a query param. It's also possible, but again, it's something we'll need to implement ourselves. We just can get whatever else is after the matched expression. So then we need to do URL parsing. The easiest way to do it, I think, is just instead of a get, just use the post and send the color as a body. And as a body we can just use plain text, hexadecimal, 3 bytes, red, yellow, red, green and blue, and take it from there. So to do that, for Rust we usually start with defining a data structure to represent what we want to do. So let's start there. We have a color. Color has 3 elements, red, green and blue, and they're all bytes. So let's call the red U8, green U8 and blue U8. Alrighty, let's derive debug, so we can just print it to check. And now we need to somehow deserialize this. I don't want to use actual deserialization. This is a bit overkill, I think. So let's parse this thing from a string, I suppose. So let's start with making a quick function, parse color, and we pass in the input, which is a string slice, and we return a color. Something like that, right? So there are actually 3 parts. We need to cut that in 3 pieces. So in order to parse it, we have a U8. There is a function, what is it, from something with radix, from string radix, yeah. And that takes a a string slice and returns the number. So we need to cut it up in pieces. So let's take 0 until 2 of string of input, obviously, and the radix probably borrow, and the radix is 16, and that is basically one of the elements. So this would be then red because it's the first one. So let's do color. Red is this one. So let's put this one here, and let's do the green. It's the same, and the blue is the same as well. Only we need to take different indexes, 2 to 4 and 4 to 6. Maybe a bit too many braces. Alright, so probably this can fail. Yeah, so we will need to unwrap that. Maybe it's better to make this whole thing fallible. It's more the best way. So we do, let's do it anyhow, sort of generic error crate for this. And then we can just add question marks here. And the only thing we need to do then is wrap the whole thing in OK. Okay, this one is happy. So this will parse a string and return if it all works out. We can do a little bit better than that because we can implement it actually inside the color. So we can do impl, and then we do try from for color, and that's implement this, and that will allow you to use from and into to transform between types. Let me redo that and add the string slice because that's what we want to try to transform from. So this works out. So we can basically transfer whatever we had here inside this one. We only need to define the error type. Anyhow error. And then this should have the same name, of course. And then it's a little bit easier. So we'll get back to this one to see if we can parse it. Now let's go to the server itself. Now it's using a get. Let's use a post. Let's import. This is a bit prettier than the whole expression. So we have a request object. Now we need to read the request object. For a get you don't need to do it. You typically don't have a body. But right now we do. So and to read something you need a buffer. So let's create a buffer. Buffer needs to be bytes. So let's start with creating a buffer, and that's something like an array of zeros of U8s, and let's make 6 of them. Right, we need 6 characters, so that in the end will transform into 3 bytes. Like that. I guess they need to be mutable. As we're reading a request, that needs to be mutable as well. And then we're gonna do a read of request, or I think even there is a better one. There's a read exact, and that will, if you know exactly how big your data is, probably need to borrow that mutably. So far so good. Let's add a question mark, Yeah, before I was unwrapping all over the place, but actually this function pointer, where is it? Returns a handler result, and that actually also include any error. So you can just use the question mark. I thought that would involve doing the map errors all over the place, but that's not actually necessary. So this is a lot nicer. So if I'm not mistaken, I can just replace this one with the question marks as well. This one too. I guess this one too. Anyway, so now we have read the buffer. Then let's convert it from UTF-8. So we can take the buffer and then we can go in try into, and we put it into a variable. So let color and a question mark. Oh yeah, we need to question mark this as well. So now we should have a color. So here we parse the buffer into a string, and then we did try into. Looking back, maybe it would be easier to implement the try from for the byte array, so we can do that in one go. It's kind of cleaner, but here we are. We did derive debug, so we can just print it for now. Let's do that. Print line color, and then we can just do like this, color, and then we have and then we'll know if it works. So let's try this. Maybe use a different path, a little bit clearer. Okay, let's see if this thing works. Let's go. Probably will fast forward. Alright, getting the Wi-Fi. It's connected, do some pings. Okay, so that's registered. Let's go back to our environment. Let's create a new request. Let's call it set color. The IP address is the same, so let's copy that from the last one. And now we need to have a post. And we need to define the body. So let's call it like 1, 2, 3, 4, 5, 6. And let's call it text. And then post. Well, let's see what happens. Oh yeah, and we need to go to /color. Right, I just changed that. Oh, it crashed, I think. It did. Let's see what happened. Okay, that's the thing I've done wrong before. That is when you create an array like this. I take a 0 of U8, and then it just interprets this 6 as the second element. So this is an array of 2 elements. What I wanted was 6 elements of these, and then you need to do semicolon. It's dumb, but not the first time. So same thing, probably fast forward. Alright, let's see if it works better this time. Starting up, doing the pings. And it's up and running, so let's go. Set color, and call it. Okay, it said still hello, so that's good. Let's see the output. Ah, yes, so 18, 52, 86. So I guess that's these three numbers in hex, which seems to be reasonable. Alright, so now the actual setting of the LEDs. Because what it actually still did was the toggle we did before. We didn't really change that. Okay. So we started with the LED pin. If you think about it, the logical thing to do is that you would not set it to true or false, but choose some float, like between 0 and 1 or something like that. That would indicate the voltage of the LED or something like that. That is typically not how it works, because that would give all kind of instability, and you don't want to have a huge range of voltages. How LEDs actually work is by switching them on and off really quickly, and the more they're on, the brighter they seem, and the more they're off, the less bright they see. So it is actually not a voltage that changes, but a timing. And changing the timing in ongoing pulses, that we call pulse width modulation, also called PWM. And that is used for LEDs, but you could also use it for sound maybe, or for servos. They also use pulse width modulation, so maybe after this we can do some other things with it. But it does make it a little bit more complicated than you might think. So to start all this, we need a timer. We need something that creates those pulses, and that goes something like this. LED timer, and that is, we need to get it from the peripherals, and we say what is it? Let's see, let's take timer 0. We have a few. We don't need to yeah, we can use multiple timers, but right now we're gonna use this one. And then we need to have a timer driver. Let's see. There it is. New. And what does it need? It needs a timer. And what else? A configuration. And that's, let me think. That's a timer config, I think. Yes, from let's see. It's important to really make sure you import the right one, because in a lot of cases there are many, and if you get this wrong, things get weird. And that will take new. What does this take? And we need to borrow. And this empty one, and then there's like it's builder pattern, I think. Yeah, frequency, and then we need a certain frequency. I don't think it matters a whole lot, but generally, yeah, I try to really scale it down, but it doesn't matter that much. So let's start with like 1000 Hertz. That should be a trait that's out here somewhere. Or am I wrong? Let me check my notes. I think we then need to import them. ESP IDF system units or something like that. Let me see, where were they? Maybe it's the hell. Yeah, units. Let's take all of them. And then yeah, the LED timer here. LED timer. And now the units work, I think. Yeah, so far so good. So what's next? And now we need to create a channel, so we can set the individual colors on an individual channel. So they have different duty cycles. Duty cycle is what we mean by how much of the pulse, this cycle, is energized versus not energized. So let's start with making a red channel, and that's then we need to make a let's see driver, new I think. So we need the driver, I suppose, and these channels are also a sort of a system resource we need to get from the peripherals. Channel, let's see it, yeah, let's call it channel 0, and then the LED timer and the pin. What did it do? Did it? I don't know why it. Oh, I changed lines. Okay, that's why I was confused. Yeah, so we have the peripherals dot let's see dot timer. No. One moment. Yeah, we do need that. Yeah, it is. Let's see, channel 0. We do the LED timer driver, and we need to take a pin. Before we were using pin 5 because that's the blue pin. Right now, this is the red channel, so we need to take pin 3. So that is peripherals and G pins GPIO 3. And let's see if that worked. Okay, and this needs to be unwrapped. Okay, and this one, that's the one I messed up a little bit. We can remove that one for now. But we do need to do the arc mutex thing, because we need to transfer it between threads. So let's do that now. Arc new mutex new, and wrap all that. Check the type. So now we have an arc mutex of the red channel. Okay, let's do the same for green and blue. They all need their own channel, if I'm not mistaken. And and their own pin, obviously. Okay, so this one we removed. So let's do the red channel, and we lock it, and then we unwrap it, and then we set, let's see what type it is. That eludes me for a moment. It's a driver. So okay, this is we still need to fix some things here. The timer driver, that should be in I think we can borrow those. Yeah, so that fixed that problem, but it still is a mutex of a result. That's not really what we want. So this thing needs unwrapping as well. Okay, so now check the thing here. That looks better. So we unwrapped it after the lock, and then we do set duty. And then in this case the duty is a byte, and luck would have it, we have a color dot red. Probably a borrow. Okay, let's cast it. Okay, and probably we need to unwrap it just to deal with the result. Let's do the same for the green and the blue channel. Color red, green and blue. Well, let's see. Here we go. All right, starting. Okay, that seemed to have started all right. Let's see what this does. So let's start with something really clear. So FF0000. So max on red, 0 on the other, so that should be red. Let's see what happens. Well, what do you know? That is nice. So let's go to the, for example, 0, 0 and then FF for the green one. Nice. If you add the red one, it will be yellow. And if you do all of them, it will be white. Sort of. It's actually quite bright. The camera doesn't really do it justice, but it's yeah, it's whitish. If you really make it very dim, so this should be very dim white, then you can, yeah, now the other one is too bright, but you can see maybe that it's actually, you can see that it's 3 individual LEDs. Maybe you can't, but it's yeah, so it works. So that was all for today. It was a bit longer than I expected, but yeah, I will continue with some HTTP things. I want to make an HTTP client to be able to reverse the calls. And if you like it, please like the video. It's dumb, but it's still motivating. And if you have some idea of what to do next, let me know. Thank you. Bye.